Welcome to Rivera Institute of Mathematical Sciences. Today we are discussing some problems of linear algebra from CSIR November 2020. First one, if capital A equal to 3 minus 2, 2 minus 1, then what is the value of A raised to 20? Okay, we know that if each row sum of a matrix is same, then it is an eigenvalue of that matrix and corresponding eigenvector is 1, 1, 1, etc. up to 1. Or we can say that if 1, 1, 1 is an eigenvector corresponding to the eigenvalue lambda of a matrix, then each row sum will be equal to lambda. Okay, for that here I suppose each row sum of a matrix capital A is lambda. So lambda must be an eigenvalue of that matrix and the corresponding eigenvector is 1, 1, 1, etc. That is, we can written as AV equal to lambda V, where lambda is the row sum of this matrix and the corresponding eigenvector is V, and V is equal to 1, 1, 1, etc. up to 1. Then what is A square V? We can written A square V as A square V equal to A of AV. And what is AV? AV equal to lambda V. So A of lambda V, and here lambda is a scalar quantity, so we can take lambda outside, that is A square V equal to lambda into AV. Again AV equal to lambda V, that is lambda into lambda V, which will become lambda square V, that is A square V equal to lambda square V. What does this means? This means that if lambda is the row sum of the matrix capital A, then the row sum of A square will be equal to lambda square, and proceeding like this we will get A power k into V equal to lambda power k into V. That is, if each row sum of matrix capital A is lambda, then each row sum of A power k will be equal to lambda power k. Okay, so move to this question. Okay, what is row sum of this matrix capital A? Here the first row sum is 3 minus 2 equal to 1, and second row is 2 minus 1 equal to 1. That is, each row sum of this matrix is 1, so 1 is an eigenvalue, and each row sum of A power 20 will be equal to 1 power 20, which will become 1. That is, each row sum of A power 20 is 1. So we can eliminate some option by verification and elimination. Here consider first option, option A. The first row sum is 41 plus 40, which is equal to 80 and not equal to 1. Therefore we can eliminate option A. Similarly option C, 41 plus 40, which is also 80, sorry, here it is 81, which will 40 plus 41, that is this also 81, so we can eliminate this option also. And here 41 plus 40, 81, we can eliminate this option also. And here 41 minus 40, which is equal to 1, 40 minus 39, which is equal to 1. Here each row sum is 1, therefore only one option is correct, that is option B. Okay, next one, let capital A be a 2 by 2 matrix with a determinant of A equal to 1 and trace of A equal to 3. Then find the value of trace of A square. Okay, we know that trace of a matrix is the sum of the eigenvalues, and a determinant of a matrix is the product of eigenvalues. Here given that determinant of A equal to 1 and trace of A equal to 3. So we can write the characteristic equation of the given matrix. What is the characteristic equation of a 2 by 2 matrix? That is lambda square minus trace of A into lambda plus determinant of A equal to 0. Here given that trace of A equal to 3 and determinant of A equal to 1. So the characteristic equation will become lambda square minus 3 times lambda plus 1 equal to 0. This is a quadratic equation, so we can find the values of lambda, and these values will be the eigenvalues of this 2 by 2 matrix. That is lambda equal to 3 plus or minus square root of 9 minus 4 divided by 2, that is 3 plus or minus root 5 divided by 2. That is the eigenvalues of this matrix. Suppose lambda 1 and lambda 2 are the eigenvalues, then lambda 1 is 3 plus root 5 divided by 2, and lambda 2 is 3 minus root 5 divided by 2. That is the eigenvalues of this matrix capital A is 3 plus root 5 by 2 and 3 minus root 5 by 2. Then what is the eigenvalues of a square? The eigenvalues of a square will be lambda 1 square and lambda 2 square. And what is lambda 1 square? Lambda 1 square is 3 plus root 5 divided by 2 the whole square, which will become 9 by 4 plus 3 root 5 plus 5 divided by 4, that is 9 plus 5 14 by 4, that is 14 by 4 plus 3 root 5. Similarly, what is lambda 2 square? We simplify like this, we get lambda 2 square equal to 14 divided by 4 minus 3 root 5. Okay, then what is trace of a square? Trace of a square will be sum of eigenvalues of a square, that is lambda 1 square plus lambda 2 square. That is, by adding these two we will get 14 by 4 plus 14 divided by 4, which will become 28 divided by 4, that is 7. That is option D is true. Okay.